So this is the solution to test number 2. Okay, so problem number 1, I asked for the solutions to this equation between 0 and 2 pi, and then for all values. And it said you could either use the unit circle or your calculator, so I'll show you how to do both of those. So if you solve for the sine of x, you get negative 1/2. So the first thing you do is you determine which quadrants you're in. This is the calculator way. So all students take calculus sine. So the sine is positive in the first quadrant, and the second quadrant, negative in the third and fourth quadrant. So what that's telling me is the solutions are in the third and fourth quadrants. Then you find the reference angle, and that's the inverse sine of the absolute value of negative 1/2. So make sure your calculator is in radians. Not degrees. So we take the inverse sine of 1/2, which is the absolute value of negative 1/2. So you get 0.523, blah, 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 blah. Then you take that number and divide and multiply by pi. So 0.523 divided by pi times pi. So what we're doing here is we're taking our result that we just got in our calculator and dividing that by pi. So you get 0.166 pi, which that's 1/6, so it's pi over 6. So that's my reference angle. Now we have third quadrant solution, and for the third quadrant the solution is pi plus the reference angle. So x is equal to pi plus 1/6 pi. So 1 pi is 6/6 pi. So 6 plus 1/6 is 7/6 pi, or 7 pi over 6. And the fourth quadrant solution is 2 pi minus the reference angle. So you get 2 pi minus pi over 6. 2 is 12/6. 6 times 2 is 12. So 12 minus 1 is 11, so you get 11 pi over 6. So those are my two solutions between 0 and 2 pi. So if I say between x is between 0 and 2 pi, x equals 7 pi over 6 and 11 pi over 6. Now if you want all the solutions, then x is 7 pi over 6 plus 2 pi times n, and the other one's the corresponding to the fourth quadrant solution, 11 pi over 6 plus 2 pi n, where n takes on all integers. So n equals 0 gives you the solutions between 0 and 2 pi. Okay, so that's how you do it using the calculator. For the solutions using the unit circle, as you need to have a unit circle, you draw a circle. Now remember, the sine of an angle is equal to the y coordinate. So you draw a horizontal line at negative 1/2, because that's what the sine is equal to. So you draw that, and then you draw 2 rays from the origin to here, one to here and one to there, and those corresponding angles. And also, if you look at the coordinates of these points here, this coordinate is negative the square root of 3 over 2, common negative 1/2. and the coordinate over here is positive the square root of 3 over 2, negative 1/2. So these both have negative 1/2. So you'd see the y-coordinate is negative 1/2, which is what I'm looking for. And these corresponding angles are 7 pi over 6 and 11 pi over 6. So that's how you would do it using the unit circle. Okay, moving on here. Number 2. So you had the cotangent squared of x times secant squared of x minus 1. And we always said that if you have stuff with squareds and you're adding or subtracting 1, then probably one of the Pythagorean identities would work. And the one involving secant is, if you look at your sheet, you'd have that the tangent squared of x plus 1 equals secant squared of x. So there's 3 Pythagorean identities. You can see if I subtract 1 from both sides, I'll get secant squared x minus 1. So what I can do is replace this with tangent squared x. But we have this reciprocal relationship that says 1 over the tangent of x equals the cotangent of x, or the tangent of x equals 1 over the cotangent of x. So probably what I do is I've replaced the cotangent of x with 1 over the tangent. So what I do here is cotangent squared is going to be 1 over tangent squared. If cotangent is 1 over tangent, then cotangent squared is 1 over tangent squared. And then I multiply by tangent squared x. That's come here, and you see this cancel out, and you get 1. 1 is equal to 1. So some of you guys made it a lot more difficult than you really needed it to be. Okay, number 3. So it says find the values of x to satisfy the following equation in the interval from 0 to 2 pi, and also for all real numbers. So I did the factoring for you. So you've got 3 cosine of x minus 1 has to equal to 0. For the product to be 0, that's one possibility. So you get the cosine of x is positive 1/3. If you solve for it, because this goes to the other side, becomes positive 1. Divide both sides by 3. And then you've got the other one, the other factor, which is 4 cosine of x plus 1 equals 0. If you solve for the cosine of x, you get negative 1/4. So in this case, you have to use your calculator because there are no values on the unit circle that correspond to this situation. But all students take calculus. So this is cosine. So it's positive in the first quadrant, positive in the fourth quadrant, negative in the second and third quadrants. So because I have a positive here, these are going to be quadrant 1 and quadrant 4 solutions, positive. Here it's negative, so it's going to be quadrant 2 and quadrant 3. So that's step 1. Step 2 is to calculate the reference angle. Now this is going to be some decimal of pi. So we take the inverse cosine of the absolute value of 1/3. And over here, we take the reference angle is equal to the inverse cosine of the absolute value of negative 1/4. The negative is telling us what quadrants they're in. The fourth part tells us what the reference angle is. So again, make sure your calculator's in radians. So you take the inverse cosine of 1/3. So that's 1.231. And then you divide that by pi. And we get 0.392 pi. Over here, we take the inverse cosine Okay, so we're going to take the inverse cosine of 1/4. So that's going to be equal to 1.318 and divide 1.38 by pi, and you get 0.4196 pi. Okay, so now step 3 is to find the first quadrant and second quadrant solutions here. So the first quadrant, the angle is the reference angle, so that's going to be 0.392 pi. So that's my first quadrant solution. My fourth quadrant solution is x is equal to 2 pi minus the reference angle. So I get 2 pi minus 0.392 pi. And notice these are both multiplied by pi, so what I'm taking here is 2 minus 0.392, and that's 1.608 pi. Over here, I've got my second and third quadrant solutions that go along with the right-hand side. So in the second quadrant, the angle is equal to pi minus the reference angle. So I have x is equal to pi minus 0.4196 pi. So you get 1 minus 0.4196. So you get 0.5804 pi. And my third quadrant solution is pi plus my reference angle. So that's pi plus 0.4196 pi. Well, that one's the easy one. It's 1.4196 pi. 1 plus 0.4196 is 1.4196. Okay, so those are my solutions between 0 and 2 pi, these three. So if I want to say between 0 and 2 pi, I get x equals 0.392 pi. That's my first quadrant solution. I've got 0.5804 pi. That's my second quadrant. I get 1.4196 pi. That's my third quadrant. And I get 1.608 pi. Now for all real numbers, all you do is you just take them and take the answers between 0 and 2 pi and add 2 pi into every one of them. So I just copy them down from the previous step and add 2 pi into everything. And again, you have to tell me what n is to specify that. So again, that's all integers. And when n equals 0, you get these solutions. Okay, the next one, you could use the unit circle or use a calculator. So you get tangent squared of x equal, or minus 3 is equal to 0. So if you add 3 to both sides, you get tangent squared of x equals 3. And if, a lot of you forgot to do plus and minus here, so you get plus and minus the square root of 3. So there's two solutions here. Tangent of x equals the square root of 3. Tangent of x equals negative square root of 3. So I'm going to do it by calculator here. Step number 1, quadrant. All students take calculus. Tangent. Positive in the first quadrant, positive in the third quadrant, negative in the second and fourth quadrant. So for this one, it's going to be quadrant 1 and quadrant 4. And this one is going to be quadrant 2 and quadrant. This is quadrant 3, sorry. Quadrant 2 and quadrant 4. Okay. Now the reference angle is going to be the same for everything here, because you're going to say the reference angle is the inverse tangent of the absolute value of plus or minus the square root of 3, but this is the plus, this is the minus. But when you take the absolute value, it just becomes the square root of 3. So again, make sure you calculate this in radians, which shouldn't have changed it. So you get the inverse tangent of the square root of 3, and that is 1.047, etc., etc. Divide that number by pi, and you get 0.3333333 pi, which is pi over 3. So now we can do the third step, which is finding the solutions in the different quadrants. Now, for the tangent, you really only need to solve it in the first and second quadrants because of the way these things are spaced. Here you go 1, 3, 2, 4. In sine and cosine, you don't. It's different. You don't skip. You don't go plus minus plus minus. So let's assume you didn't know that. So the first quadrant solution, x is equal to x prime, so it's pi over 3. Again, to go with this plus the square root of 3, the next thing is the third quadrant. X is equal to pi plus x prime. So you get pi plus pi over 3. So that's 4 pi over 3. Over here with the negative square root of 3, you get the second quadrant solution, which is pi minus the reference angle. So you get x is equal to pi minus pi over 3. So that's 3/3 minus 1/3. So you get 2/3, 2 pi over 3. And your fourth quadrant solution, x is equal to 2 pi minus x prime. And so you get 2 pi minus pi over 3 again. This is 6 pi over 3. 2 is 6 over 3. 6 minus 1 is 5, so you get 5 pi over 3. So these are my 4 solutions between 0 and 2 pi. So that's going to be pi over 3. Second quadrant, 2 pi over 3. Third quadrant, 4 pi over 3. Fourth quadrant, 5 pi over 3. Now as far as all real numbers, there's 2 ways you can do it. So method 1 is you just take each one of these and do what we normally do. Add 2 pi in. And again, n are all integers. When n equals 0, you get the solutions between 0 and 2 pi. But you could also do this, and a few students did it. You can take your first quadrant solution and add pi n, and take your second quadrant solution and do pi n. And again, n would take on all integers. Now to get the solutions between 0 and 2 pi, you'd have to use n equals 0 and n equals 1. If you put n equals 1, you get 4 pi over 3 and 5 pi over 3. This only happens with tangent, that you can write this abbreviated form. Now as far as finding the solution here using the unit circle, it's not quite as easy because normally you don't have tangent on your unit circle. But if you did, what you'd find out is that pi over 3 would be here, 2 pi over 3 would be there, 4 pi over 3 would be there, 5 pi over 3 would be there, and all of these have the same relative size of the x and y coordinates. All you get is different signs. So that's kind of how you do it, but I think it's in this case easier to not worry about that, especially since you don't have tangent on the unit circle. Okay, number 5, a lot of people got that wrong, but I'm going to show you how to do it. So you get the sine of 3x equals 0.6. And even though we did it in the homework, talked about it in class, I'm not sure why everybody still did it. Some people divided by 3. Sine of x equals 0.6 divided by 3, but you can't just take the multiplier inside the argument and move it out. It's not multiplication or simple arithmetic. So what I've said multiple times is that you can redefine 3x as just theta, and then we'll find the solutions for theta, and then we'll just then we'll know x is going to be theta over 3. So we'll get the solutions for theta and just divide everything by 3. That's the idea here. So what we'll do is we'll just start all over and just replace 3x with theta. Now it's exactly like we've done in the previous problems, except I've got this different variable name, but that's it. And I've got this so that you can't use your unit circle to get the solutions. So all students take calculus. The sign, we did this on the first problem. It's positive in the first and second quadrants, negative in the third and fourth. So in our case, we have a first quadrant and a second quadrant solution in theta. So that was step 1. Figure out which quadrants we're in. Number 2, find the reference angle. So since I'm using theta, I'm going to call it theta prime. So it's the inverse sine of the absolute value of 0.6. Okay, so we take the inverse sine of 0.6. So that's 0.6435 divided by pi. So we get 0.2048 pi. Okay, so that's our reference angle. Then we find the step number 3 is we find the solutions in the appropriate quadrant. So theta is theta prime in the first quadrant. So that's 0.2048 pi. And our second quadrant solution, theta is equal to pi minus theta prime. We're just replacing x prime with theta prime. So we take 1 minus 0.2048, 0.7952 pi. So that's the second quadrant solution. Now, what we'll do is we're actually going to do it for all values of n, and then we'll choose n equals 0, 1, 2, and 3. And that's because we're going to have 3 times as much happening in a certain amount of space on the x-axis. So step 4 here is to actually say theta for all values of theta is going to be 0.2048 pi plus 2 pi n. But remember, x equals theta over 3, or theta equals 3x. So what I'm going to do here is I'm going to take all of these decimal things and divide by 3 to get x. So if you take 0.2048 and divide by 3, you'll get 0.0683 pi plus, I'm just going to leave it as 2 pi over 3 n. And then you have the second solution, which is going to be this number. So let me put it in terms of theta first. So in terms of theta, it's 0.7952 pi plus 2 pi n. But, x is theta over 3 again, so you're going to take 0.7952 pi and divide by 3. And then you're going to take 2 pi over 3 times n. So divide 2 pi by 3, you get 2 pi over 3. So let's go ahead and do the calculation there. 0.7952 divided by 3 is 0.265 pi plus 2 pi over 3 n. And n goes as such, as it usually does. So that's the solutions for all values. What we're going to do is we're going to, step number 5 here is we're going to do n equals 0, n equals 1, and n equals 2. So for n equals 0, you just drop this 2/3 thing. So we'll take this thing. So for n equals 0, you get x equals 0.0683 pi, and you get x is equal to 0.265 pi. Now for n equals 1, you're going to have this number, 0.0683, plus 2/3 pi. So we'll just, so it's going to be 0.0683 plus 2/3. So what we're doing is we're taking 0.0683 pi plus 2/3 pi. So that's this plus 2/3, 0.666. And if you do that, you get 0.735 pi. So that's for this one here. The next one you take this second one, 265 pi plus 2/3 pi. So it's 0.265 plus 0.6666, 0.265 plus 2/3. So you get 0.932 pi. So that's my next two solutions. And then I do n equals 2. So what I'll get is x is equal to 0.0683 plus 4/3 pi. Because here it was 1 times 2/3, now it's 2 times 2/3, which is 4/3. That's 1.33, so if you take 0.0683 plus 1.333333, you get 1.402 pi. And then you take the second solution, which is 0.265 pi plus 4/3 pi. So we add 0.265 plus 1.333, and we get 1.598 pi. So those are my solutions, 6 solutions between 0 and 2 pi. Normally I would get 2, but because it's 3x, I get 6. Okay, number 6. So what we have is theta is equal to 7 pi over 12. And what we need to do is rewrite this in terms of angles that are on the unit circle. And because we have 12ths, one of them's got to be something over pi over 4, right? Which is the same, if I do that in 12th, that's 3 pi over 12. So the question is, if I need 7 pi over 12 and I've got 3 pi over 12, what do I have to add to it? I have to add 4 pi over 12. But 4 pi over 12, 4 divided by 12, that's 1/3, so you get pi over 3. So that's the initial thing you have to do. You have to figure out that 7 pi over 12 is pi over 4 plus pi over 3. Now that we have that, we're using the sum and difference formula. And the sum formula says, because we're adding stuff here, it says the sine of A plus B, or U plus V, however you want to do it, is the sine of A times the sine or cosine of B plus cosine of A times the sine of B. So let's see what we have here. So the cosine of pi over 4 is the square root of 2 over 2. The sine of pi over 4 is the square root of 2 over 2. They're the same thing. And pi over 3, the cosine of pi over 3, you can get these off the unit circle, is 1/2, and the sine of pi over 3 is equal to the square root of 3 over 2. So just look those off a unit circle. Or you can plug them into your calculator. So what we end up with is if we have the sine of A plus B, it's the sine of A. So we'll call this A and we'll call this B. So we get the sine of A, which is the square root of 2 over 2, times the cosine of B, which is 1/2. And we add the cosine of A, which is the square root of 2 over 2, times the sine of B, which is square root of 3 over 2. So that's the square root of 2 over 4 plus the square root of 6 over 4. And we have a common denominator, so you get the square root of 2 plus the square root of 6 over 4. So that's the sine. Now the cosine formula, cosine of A plus B, is the cosine of A cosine of B minus the sine of A times the sine of B. So again, we can take these values. I'm just going to do it down here because I want to see everything. So the cosine of 7 pi over 12, which is the sum of these two angles, is the cosine of, I'm just going to look at it here. So you're going to have the cosine of A, which is the square root of 2 over 2, times the cosine of B, which is 1/2, minus the sine of A, which is the square root of 2 over 2, times the sine of B, which is the square root of 3 over 2. So when you multiply these together, you get the square root of 2 over 4. And when you multiply the square root of 2 times the square root of 3, you get the square root of 6 over 4. You have a common denominator, so you get the square root of 2 minus the square root of 6 over 4. So that's the second answer. And then your final problem, so it says if the sine of some angle theta is negative 3/7 and theta is in Q3, what are the sine and cosine of 2 theta? So these you have to use the double angle formulas. There's one double angle formula for the sine and 3 for the cosine. So let me just write out the formula. So the sine of 2 theta is 2 sine of theta cosine of theta. And the one that I'm going to use for the cosine, doesn't really matter which one you use, it's going to be 1 minus 2 sine squared theta. So that's one of the three. You can use whichever one you use is going to work out. So to be able to plug it in, we need to know what the cosine is, because we know what the sine of theta is -3/7. So the question is, what's the cosine? Well, if you remember the third quadrant, all students take calculus. Pretty getting tired of that, but it's useful. Cosine, positive in the first quadrant and the fourth quadrant, negative in the second and third quadrant. So the cosine of theta is negative something. Cosine of theta is negative. Okay, a lot of you guys didn't recognize the negative thing, and that comes from the third quadrant information. Now once you've got, and we also know that the sine, positive in the first and second quadrant, negative in the third quadrant. So what I gave you agrees with what you should get, that they're both negative. Now there's two ways you can do this. You could plot this point in the coordinate system, Cartesian coordinate system, and because this is always positive, this really has to be -3 divided by +7, because this is the distance from the origin to that point in space. And the y value is -3. So if you go down 1, 2, 3, -3, it's somewhere along this line, and it has a radius of 7. So this is 7. This is -3, and because we're in the third quadrant, this part of the triangle has to also be negative. So the coordinates of this point, we don't know. We know the radius and we know y, but we have r squared is equal to x squared plus y squared, or y. We have y. We're trying to figure out x. So x squared is equal to r squared minus y squared. So we get 7 squared minus -3 squared. So that's 49 minus 9, which is 40. So x squared equals 40, or x equals plus or minus the square root of 40. But in the third quadrant, x has to be negative, so it's going to be negative the square root of 40. So this point here is the x coordinate, which is negative the square root of 40, comma, -3. Negative square root of 40, -3. If I square this and add to this squared, I'll get 49, square root of 7. Okay, so from that you can remember the cosine of some angle theta at any point, any value, is equal to x over r. Well, x is negative the square root of 40, r is 7. So that's the cosine, negative the square root of 40 over 7. The other way you could do it is you could just make a triangle up, where this is theta. The sine is the opposite over the hypotenuse. So we have 3 and 7. And I'm using positive numbers because it's a triangle, not coordinates in a plane. So if you use the Pythagorean theorem, you'll get that the adjacent side is the square root of 40, just like that. This squared minus that squared is 40. Take the square root, you get the square root of 40. So from that, you'd say the cosine of theta is adjacent over hypotenuse. But since we're in the third quadrant, you have to say the cosine of theta that we're going to use in this is actually negative the square root of 40 over 7, because we made that decision here somewhere earlier. Okay, so now we got the values of the two angles. We know that the sine of theta is negative 3/7, and the cosine of theta is equal to negative the square root of 40 over 7. So, plugging into this formula, the sine of 2 theta is 2 times the sine of theta times the cosine of theta. And so if we multiply all the numerators together, we'll get these negatives will cancel out. 2 times 3 is 6, so we get 6 times the square root of 40 over the denominators multiplied together, which is 49. So you get 6 square root of 40 over 49. And the cosine of 2 theta is 1 minus 2 times the sine squared. So we get 1 minus 2. This squared, the negative sign will become positive. You get 9 over 49. And 2 times 9 is 18. So you get 18 over 49. 1 is 49 over 49. And 49 minus 18 is 31 over 49. So they're both positive. Both the sine of 2 theta and the cosine of 2 theta are positive. And that is it. So if you go back to the review and look at all those problems, you'll see that there were no surprises. So that's why I'm not super sympathetic to try to give you extra credit for anything, because I think that the review and the material was sufficient to do well if you study properly. So